Hi, I'm Brian Iverson. I'm the Tstud guy. We're in the basement of my garage where we first started this out back in 2015. So I'm going to talk to you about the Tstud, the entire Tstud wall assembly, how it's put together. The first thing I'm going to start out with is why. We built a complete thermal break through the wall stud itself. So we have 2x3, 2x3, 2.5 inches of foam core, and it's held together by just a parallel cord truss. I can't say it's just a parallel cord truss because it's taken a long time to get here and get this figured out. But this is what's inside of the Tstud. The R value through the wall assembly, not including the windows and doors. So all the walls, no floor, no roof, no basement foundation, just the wall assembly itself. The windows and doors make up roughly 10%, so we're going to talk about 90%. So in that 90% with the Tstud, with this foam core in the middle, the average R value that you get through the entire wall assembly is 23.52. It just so happens that that's exactly the same R value that you get if you put continuous rigid insulation on the entire outside of the structure. So continuous insulation on the outside, 2x6 construction, 16 inches on center. You have all the thermal transfer through the studs, through the top plate, bottom plate, through the headers. You got thermal transfer everywhere. And then you put the foam on the outside. That R value is 23.52 as well. So that makes up the average R, the average U value will end up being 0.0425 with a R21, 20 or 21 bat in the middle. So in Minnesota where we're at, an R21 is what we need to have in climate zone 7, and it's 23.52. How long does it take to actually pay back the cost that you're going to invest or your clients are going to invest into the Tstud? Running Fourier's law, which is the law that was put into place back in, I shouldn't say a law, it is a law of physics that's been put in place since the 1800s that every insulation manufacturer has used to date to calculate energy efficiencies and how do you calculate the R value of your foam or any insulation at all that's in the cavity. So it's called Fourier's law. So Fourier's law, it's roughly 20,000 BTUs per hour that you end up saving by using the Tstud. And the payback in Arizona is 3.22 years, going by just the average R value for every single month for entire year over the beginning of time, since they started calculating or recording history of R value, or temperature changes daily. Okay, so the payback in Arizona is 3.22 years, going by Fourier's law. Minnesota, 5.6 years. Michigan, 5.6 years. Maine, 5.6 years. Florida, 3.22 years. You see, we heated up one wood member to 194 degrees, and we only had 3 degrees temperature transfer to the other side in an hour and a half. So you can't say the word stopped, but we have absolutely minimized the ability of any cold or heat to transfer from one side to the other through the Tstud, and it takes 2.5 inches. That's our magical number that we've been working with in order to build the Tstud. Okay, that's it for the paybacks. Understanding that we are working with the energy rebate programs in 19 states currently to get the entire upcharge up to $3,500 covered. Not that it's $3,500 to use the Tstud, but that's what we're going for with the energy rebate companies, energy with the utility providers. Okay, strength, 2x6s. I don't care what they're made out of, LSL, LVL, SPF, SYP, whatever letters you can come up with. They all fail in the 1.5 inch axis, all of them. The Tstud, when we turned the wood members perpendicular, built the truss system in between, injected the foam in between. This is Y, this is X. So all lumber fails in the X axis. What we did is we stopped the ability of this to deflect in X or in Y. The only way the Tstud fails now is in Z, which is fiber upon fiber going straight down. So a Tstud, 8, 9, 10, 12 feet tall, is certified to hold 8,600 pounds. You can't use 8,600 pounds unless you put this on steel. So if you put this on SPF, regular SPF is certified to hold 3,665 pounds. If you take SPF, and you make it like MSR, machine stress rated lumber, so the highest old growth timber that we have in the country. Well, I can't say old growth because they make MSR out of SYP as well, southern yellow pine. But you get that modulus of elasticity up to 2100, so it's extremely dense and strong. Then you can get up to 5,600 pounds compression perpendicular to grain. And if you put this on steel, I know, a steel plate on each side, and then put that in between, you can get up to the 8,600 pounds. Do I think you're gonna do that? No, I don't. But that's the strength of this. One Tstud, 2 feet tall, 38,000 pounds. That's what it held before it failed. Catastrophic failure event. Because the structural strength of one Tstud is so significant, almost all the builders, actually all the builders so far, have used it at 24 inches on center except for one. And that particular homeowner, a shareholder actually, is putting stucco on the exterior, and all stucco manufacturers require maximum spacing of 16 inches on center. So everybody else has gone to 24 to use the structural strength, but in doing so, they have gone to 1/2 inch high strength drywall on the inside in order to firm up, rigid up the drywall rather than going to 5/8 inch drywall. At 24 inches on center, yes, I realize that it's a premium product, but this is how you're gonna help pay for it for your client and your customer. And actually, I'm gonna teach you how to save some money yourself, hopefully, maybe not on the first house or the first structure that you put up, but in the future. If you do go 24 inches on center, on average, you save 58 studs. And you also save 2,000 fasteners that go with the 58 studs. Now, will you see a savings on the first structure or the second structure? No. And the reason for that is most contractors, carpenters don't know how to do advanced framing. It's not their fault, they just haven't been required to or haven't needed to figure that out. But here we come. So I'm gonna teach you about advanced framing today. Little tricks, little nuances. Otherwise, it's just one top plate, one bottom plate, stud, cripple, take your 2x6 out, stick in a Tstud, and that's it. You still have king studs, still got jack studs, still got cripples, sill plate, sole plate, all of that is still all the same. There's just a couple little things that I gotta teach you. The first thing we're gonna start out with is treated plates, the treated Tstud, green treated plate. What we can do, and we got this approved, is take a 2x6, we get to rip it in half, make the size of 2 2x3s out of it, and then this can be placed on concrete. The one thing you gotta remember is that the green part that we cut, the original portion that's got the walmanizing on it, that has to go against the concrete. In all actuality, this will have a white portion, and so it's white side up when you're using the green treated Tstuds. Next thing, I'm gonna apologize for this in advance. You actually have to use a 5/8 inch anchor bolt. So the stocking yards are gonna have to stock these for your concrete guy, 5/8 inch anchor bolt, and the reason for that is all Tstuds are able to be used in all hurricane areas and all seismic areas, no matter where in the country. So we make them in Minnesota, eventually we'll make them in Maine, Michigan, Montana, and we're looking at property in Oregon. Okay, so same challenges. What potentially can happen, so I'm gonna blow this out of proportion, is you get a 220 mile an hour category 5 hurricane. There's so much lateral forces on that wall, it's trying to move it this way, and there may potentially, you might be able to get this to tip or twist in that hurricane area. If this was a regular 2x6 at the bottom plate, it wouldn't happen. But for the Tstud, because we have the foam, there is the chance it can tip. So we had to go from 1/2 inch to 5/8. Okay, next thing, we make the official Tstud anchor plate, 3 inches by 5 inches, hole in the middle, 1.5 inch screws on the outside. Put your washer down, and obviously your bolt's gonna come up from the bottom, fasten it down. This also requires that your cement head is gonna have to line up these anchor bolts pretty good in order to get them in there. There is some play and some moving around, 1/2 inch, 3/4 of an inch that you can do in order to make this work. But that's how it has to go down. Obviously, you're gonna do your mastic and sill sealer and whatever else that you have below that. Also, when you're doing this was concrete block, and you're gonna set your window in, remember this is 2.5 inches thick, so make sure that you're opening for your window or whatever you're framing in, like for the basement lower level, make sure you got enough room to be able to get this to fit. So put your anchor bolt in there, fasten it down, and then just take your Sawzall out and just go ahead and cut off that anchor bolt if that's the case of how it's gonna sit in there to make sure it's out of the way. So that's how you use the official Tstud treated plate up against concrete.
There you go.
All right, we're gonna start going through the process of how to frame using the Tstud. So there's the little nuances that we have to go through, start to finish. So we're gonna start from the corner. You do your normal layout, 16 inches on center, 19 diamond, 24 inches on center. You do that how you normally do, nothing any different. When you get to framing in the corner, you have this wall runs that direction, obviously this wall runs this way. You only have one stud in the back going that direction, one stud this way. But then you need a nailer for your drywall. But when you do this nailer, you're gonna create, this is for the insulator as well, you're gonna create a blind pocket in the back here that you have to get back here somehow and insulate. You just have to wrap around because you don't want your nailer touching the outside T-stud. Otherwise you have that thermal transfer through the corner, and the whole goal here is to have a complete thermal break through the corner, and that's what we have. So you have to make sure your nailer is in place, fasten it, 2 nails or 2 screws up there, same thing down there, shoot right through here, grab a hold of it, shoot through the backside, however you want to fasten that together. Next thing is the interior wall connection. What we did here and what most people have been doing so far is they will use a 2x8 for their drywall nailer. Wherever they have an interior wall coming in, the interior wall will come in and they'll go ahead and nail or screw the interior wall directly to the nailer. So your bottom plates are normal, this section is normal. What you end up with is a complete thermal break all the way behind your interior wall. I know you might end up with a T-stud landing behind here, so you'll have to figure out your nailers, but this is in a perfect world. You have a complete thermal break through the backside and you can insulate, run your wires behind and do whatever you need to do. Regarding fastening the interior wall to the top plate, there's a couple of things that you can do. Right now this is fastened, they use 3 nails up here in the top, 3 nails in the bottom. You'll have to check with the official T-stud field guide. That's we're going to keep it up to date all the time on the internet. I was at Simpson Strong Tie the other day and they said to attach this to the back like this to catch the back stud, the back wood framing member. Catch this in the front, and then this will give you all the fasteners that you need to have with your pin nailer to be able to catch the interior wall. The exterior corner, standard, this is a continuous roll of 250 feet long. Again, Simpson Strong Tie, that's their product right here. You have to have 6 fasteners one way, 6 fasteners the other. This is 24 inches to do the outside corner. Pretty simple to use, but that's normal in advanced framing. The inside corner, you can either run the same 18 inches of interior, the same kind of strapping on the inside, or Simpson makes this little fitting right here that we have shown up there to tie that corner in. Pretty simple to use. Okay, so that takes care of the interior wall, that takes care of the corner. I'm going to tell you right now that if this window is right next to this corner, you have to think about which way you're going to start your corner so that you don't end up with a blind pocket like we used to have back in the old days when we had a 4-corner pocket and we insulated them from the outside on the job before we were smart enough to turn them around to insulate them from the inside. So the rest of the framing is normal. Jack stud, king stud, sill plate, but we're going to talk about the headers themselves. The top plate is 1.5 times the strength of 2 2x6s in plank. So in a no snow load area, so in the southern part of the United States, this top plate is actually your header over a 4-foot wide window, I know on a Rambler. Okay, so this is your header, that's all you need to have. where we got snow load and you're carrying a bigger load up on top, because this is so strong, every builder so far wants to use the strength of the top plate as part of their header design. In order to do that, you gotta build your header together. If you're using T-studs, I guess it doesn't really make a difference what you're using for your header. You push the header up against the top of the top plate so that this becomes an integral part of the header design. But then that causes you to put a nailer in for the top of your window. Well, what we found to work out the best is to go ahead and fasten this to your jack stud before you obviously put your king stud in place. The headers, stack them together like normal. I would make your jack stud pretty tight so you can pound this into place to pinch this together. So here's what the header ends up looking like. So it's all squished together. This is if you use a T-stud one. There's no air transfer in between the layers because we got the foam so tight going in between there. What we did is we went ahead and screwed this together or nailed it together to make it nice and tight, and then we slammed it up to the top, obviously. When you build that header, you cannot put a splice in the top plate above the header if that top plate is part of your header design. If it's not part of your header design, then I would go ahead and put your splice on top of all those headers as you possibly can. When you're framing in the kitchen window and you need to get a vent pipe, the carpenter needs to remember a couple of things. Okay, first thing is the T-stud frame, so it's got that truss system inside. One side the dowels stick out, the other side the dowels do not. The wall doesn't care when you build it, this way, inside, out, doesn't make any difference. We don't care. The wall doesn't care, the T-stud doesn't care. The only time you care is when you have to plumb for the kitchen sink. So you got a dowel here, right directly, split the difference. Right in the middle, you have room for a pocket to run your 2.5 inch vent pipe or 2 inch vent pipe. Right here, same thing, where you have this dowel going that way and that dowel going that way, you have another pocket right here, you have another pocket right there. If you need to, if it ends up going together like this, and the carpenter doesn't line up, like what we were able to do here is, we purposely lined up, and this is what we have the carpenters doing, is purposely lining up all the dowels all the way across, knowing that sewer line is gonna head that way, and the vent pipe then can run north and south through the wall. That way they were able to miss that section right there. But if you happen to hit the dowel and you cut it, I'm gonna tell you to take out your screwdriver, and if you don't know where these line up, just try to poke a couple holes in there in order to find out where it is so you can avoid it. But if you happen to cut through one, you can cut through one. And then your repair in the field, this is a Fasten Master, 4.5 inch number 14 screw. It's a headlock screw. You can run one headlock screw above it and one below it after you put your vent pipe in. I'm not sure, maybe you might have a heating vent in there as well. But you can put one on top and one below, and that's your in the field repair. Because it catches, you gotta use a 5 inch, not a 4.5. You gotta make sure that you get all the way through to catch that backside, but don't try to pinch them together. You just need to snug it up to make sure that there is no bending in that wall. There's not that many loads when you start talking about cripple studs, but if you were in the middle here and you tried to catch your full stud and you cut 2 or 3 of these off, you're gonna damage the structural integrity of that stud, so it won't hold as much of a load. So same thing for the electricians. Electricians, they haven't been drilling holes. They've been just poking a hole with the screwdriver, stick in their flat screwdriver in, ream it out a little bit, stuff the wire through the wall. Okay, so there's the plumbing wall. We got our 2.5 inch sewer line going, 2.5 inch vent pipe going north and south. And then we have the electrician. The electrician, there's a fastener, and we'll show this to you on the field guide. You want to make sure that the wires are held back the minimum of 1.5 inches, and your vapor box, your electrical box, you have to make sure that the nailer hits the 1.5 inches. There's plenty of these to be made. There are manufacturers that are looking at moving their nailing flanges around to be able to accommodate the Tstud, but there are plenty of them available today. Just make sure you buy the right ones, so you don't have to put a nailer. I've seen the very first house when we didn't have the right ones sourced. We put a little 2x3 nailer in here in order to fasten farther back on it, and we want to try to avoid any extra labor in the field. Okay, so we talked about the bottom plate, studs, cripples, king studs, fastening the header to the top, just as you normally do. Whatever you do in the field today, those things are still true. When you're building, okay, it's 2.5 inches thick, you can't use a 3.5 inch nail. So I'm gonna give you the negatives. You gotta buy yourself a new nail gun. This happens to be a Fasco nail gun, great friends of mine. This is 2.5 inches thick, so you have to have a 4-inch nail gun. So yes, you have to go buy a new nail gun. You gotta buy a new hose, 3/8 of an inch hose, and you can look at all of our notes on tstud.com to find out all the challenges that come with this in the wintertime when your hose lays on the ground and gets cold. But it takes a little bit more of a gulp of air, 120 PSI at the gun, no problem. Nobody's had a problem so far with the sourcing out nail guns or sourcing out 4-inch nails. And the only little challenge that we have today is fastening the bottom plate of your wall into the floor truss or into the rim of your flooring system, because you got to go through the 2.5 inches of Tstud, 3/4 of an inch of flooring, and you have to have 1 inch of penetration into the floor truss or your floor joist itself, which means you have to get to 4.5 inches. I'm not going to tell you to do this, but right now you can use a Big Bertha nail gun, weighs 15 pounds. They make a Diet Bertha gun, weighs 13 pounds. You can nail them that way, or Fasten Master, GRK, and Simpson Strong Tie. Lots of manufacturers out there with 4.5 inch screws, so you can screw it down today. You can take out, like the old school days, like me, we used to hand frame them all, so taking out a 4.5 inch nail was no big deal. In the future, they are gonna make, we have a couple companies looking at making their 4-inch nailer to be able to shoot a 4.5 inch nail so that we can solve this, but we're probably 6 months out with testing, so it's not available today. So that's your one challenge you're gonna have in the field. Okay, lastly, we're gonna talk about lumber. LSL, LVL, yes, we've made T-studs out of LSL and LVL, and they're perfectly straight, a little bit heavier. They're nice to work with, the whole 9 yards, but the cost is a little bit too much today. And so we have sourced what we call a visual grade lumber, no more than 1/8 of an inch twist. Doesn't mean it's always gonna come 1/8 of an inch twist and 8 feet, but we're trying to source the straightest material that's possible in a 2x3. In the Northern Hemisphere, all lumber twists to the right. So we're fighting, just like what you are on the job, with twisted lumber. We're trying to minimize the ability of that lumber to twist. So we have sourced all of our top plate and all of our long lengths. It's called the long finger joint. Not the finger joints themselves, they also have to be a structural finger joint. That's gotta be totally certified and approved. So that part goes together great. But we're trying to use 6 and 7 foot pieces in order to make long finger jointed studs, in order to make our tall wall 12, 14, 16, 20 foot tall studs. Same with all of our top plate and bottom plate material. Just try to get them as straight as we can. The 8 foot, 9 foot, 10 foot stud lengths are visual graded as well. And so we're doing our darndest to make sure that we send and ship out the straightest material that we can possibly buy. And we're doing all that we possibly can. But if it does have a twist in it, and there's gonna be some in the stack that are gonna have a twist in it. Right now I'm gonna talk about the maximum to be the worst is 1/2 of an inch out of twist. But even if it's 1/4 of an inch out of twist, not like 2x6s that you use today, where you can put if you're on the ground, you can twist it to the left or to the right by your hand. Because that truss that's on the inside, you can't twist it by hand. So we came up with the official redneck tuning fork. You just take your T-stud, slip it over the top, and give it a little twist in order to then fasten your nails into the top, you have to use 1 nail in the bottom member, 2 in the top, so you have to have 3 nails just like a 2x6. But you had to come up with you needed a little help. So rather than trying to make tuning forks and ship them and sell them to you, just go cut one of these out on the job just like what I did. And grab a hold of it from the top and pull your stud over as you need to. Probably 80% of the studs you're gonna get are under 1/8 of an inch twist, maybe under 1/4 of an inch twist, but you're gonna have that 20% where maybe a few of them are gonna push that 1/2 inch mark. And you're gonna need a little help straightening it out. Just build one of these for yourself. We could make them out of LSL and LVL, but they'd be probably 40% more money than where we're at today. Today, it appears that we're roughly the same price as an LVL stud, but obviously you get the structural advantages. We're twice as strong as an LVL stud. You get the complete thermal break through it. You get the R value. You get a payback. And that top plate, the Y direction, the 5.5 inch direction, that passed a E84 flame spread test. So you can see it in tstud.com how that result was. But even after the test, we still had 90% structural capacity left over. And your 2 2x6s in the same test, there's nothing left of them. So your roof was already on the ground. So in a nutshell, that's how you put it all together. Sorry it took so long, but welcome to the Tstud family.